Hello everybody, this is a snapshot on truth values and statements. You should be familiar with the following concepts from either listening to lecture, reading the book, reading my lecture notes. You should be familiar with the four connectives, or, and, if then, if and only if. What we mean by a compound statement, simply a series of simple statements joined together by the four connectives. The dominance of connectives. Dominance meaning which one do you do first? Order of operations kind of thing. First comes if and only if. Then you look for the if then. Then you look for and or, left to right. Converting to and from symbolic notation. That's another worksheet. All right, so now you should start answering questions before you actually see me write the result down. So again, stop, practice, and play, right? All right, so here we go. Recall, this notation means what? Stands for the word and, meaning P and Q have to occur, right? P and Q, the word and means both of them, right? So it means both P and Q occur, right? This notation here stands for the word or, meaning at least one of the two occur. At least one of them occur. Next one, P implies Q. This is the if-then statement. What this means, if it's the case P occurs, then Q has to occur. So in the case P happens, then Q must occur. Now when P does not happen, this statement says nothing. When P does not happen, this is a statement not about that situation. This is a statement that when, in the case P happens, we know Q must happen. The last one, P if and only if Q, stands for basically they both occur or they both do not occur. They both occur or they both do not occur. Oh, that's all right. Sorry about the small handwriting there, but anyway. So, and means both occur, or means at least one occurs. If then means in the case P does occur, then Q has to occur. But again, this is the weird one because it's only about when P happens. It says nothing about when P doesn't happen. The last one simply says they both occur or they both do not occur. They happen simultaneously. All right, moving on. Okay, what's important here is knowing the truth values associated with the connectives by memory. You need to know this by memory for your final exams. The disjunction, the or statement, is true when at least one is true. So here's P or Q. This is true when at least one is true. The conjunction and, P and Q, that one's true when both are true. The biconditional, if and only if, P if and only if Q, is true when they both have the same truth value. Remember what we did on the previous slide. On the previous slide, we said they were either both occur at the same time or they don't occur at the same time, right? So when they both occur, both of them's true. When they both don't occur, both of them's false. So this statement is true when both have same truth value. Okay, so this is what you should have written down. Or is true when at least one's true. And is true when they both are true. If and only if it's true when they both have the same truth value. Then we have the troublemaker here. And the reason it's a troublemaker, if you look at the previous three, all three of those are commutative, meaning you can switch P and Q around, and it's the same statement. But the if-then is a directional statement, meaning in the case P happens, then Q must happen. That is not the same thing as saying if Q happens, then P must happen. So this one has a direction to it. So we memorize actually when this one is false, because it's only false when P is true, Q is false. And I like to simply say when a T gives an F. When a T gives an F, this statement is false. Otherwise, it's true. So again, the three at the top, we memorize when they are true. The conditional, we memorize when it is only false, when a T gives an F. You need to have these memorized. And then, of course, the negation of a true is false. The negation of a false is true. So before we get started, what is the dominance of connectives? I sort of like to say the dominance is really telling you how you split the statement up between left-sided and right-sided. You see me talking about that in another video. Okay? The dominance of connectives, if and only if comes first. So in other words, if I see an if and only if, I split left side to right side. Then the if then. Then I look for if then. Again, if I find an if then, I split left side from the right side. Then we look left to right. So and or, we go from a left to right direction, whichever comes first. So one quick example I'll give you here. Let me just kind of erase this right here. Well, I'll just put it down here, right? Okay, if I had P and Q implies or, if and only if P or Q, this is the way this would actually be split. If and only if comes first, so left side, right side. If then comes next, so left side separated from right side, and I'd be done. Moving on. So now we're going to walk through several statements evaluating whether or not it is actually a true or false statement. In the first three here, I've actually inserted the truth values into the statement. So you need to determine whether or not each one of these is true or false. So again, it's suggested you stop the video, work the problems, now watch the video. Now let's move on. Alright, so I always work inside parentheses first, right? When this is an and statement. And is true when they both are true. So this is false. I still have the negation here. I still have the direction. Dominance does play a part here. But again, we always work inside parentheses, right? Alright, now on the left-hand side, I have to do the negation, right? Because remember, this arrow separates the left side from the right side. So the negation of a false is true. The if then is false only when a T gives an F. That's not the case here, so that's a true statement. Moving on to number 2. Again, pause the video. Working inside parentheses, I have an or is true when at least one of them is true. Over here on the right side, I have an if then. When a T yields an F, that's a false statement. I'm working with an if and only if. they both have to be the same. They are not. Since they're not the same, this is a false statement. Number 3, I didn't really leave myself any room here, but hopefully I can get through it. Inside parentheses, this is an and is true when they both are true. This is an or is true when at least one of them is true. This is an if-then. If-then is false only when a T yields an F. That's not the case, so this one's true. Moving on. Okay, for number 4, I'm giving you a statement here, and I'm assuming that P is true and Q is false, and I want to know the truth value of this statement under this scenario. So since we're assuming P is true and Q is false, our first step is to replace P and Q with their values. P is true and Q's false. P's true, Q's false. Now, like on the previous slide, I'm going to start working this out. Inside the parentheses, this is true and true, right? Because I have to do the negation of F. How can I join two things together when I don't know what the operand's value is, right? So I negated the F, right? Continuing on, working inside parentheses. And is true when they both are true, right? Okay. I think I left off one of my parentheses there. No big deal. All right. Now when I look at this, inside the parentheses, I have an if-then. That one's true, because the only time that one's false is when a T yields an F. So I have a true and a true. So this answer is true. This statement is true under this scenario. There are 4 possible scenarios here. You think about it. P and Q both could be true. P could be true, Q could be false. P could be false, Q could be true. And then they both could be false. But under this scenario, we know whatever was said here, it would be a true statement, meaning did not contradict myself. Workout number 5. I'm assuming P is true, Q is false. Now, I'm going to insert the values. Not true implies false. If and only if. True implies not false. So I'll replace P with true, Q with false. Now work it out. The negation of a true is false. Over here, the negation of a false is true. On the left side, if then, that's a true statement. Notice 2 F's gives a T. That can happen, right? Because I didn't contradict myself. So again, you have to it might help thinking like that. Oftentimes, I like to say in class, I am checking to see if I contradicted myself or not. I don't really like to say sometimes and think in terms of true and false necessarily, because here 2 things are false, but yet it's a true statement. You might find that a little weird, but think in terms of contradiction. Over here on the right side, true gives a true. That's true. And if and only if is true when they both have the same truth value. They do. So this is a true statement. Number 6. Again, we have a statement. We're assuming P is false. We're assuming Q is false. We insert their values into the statement. First step, right? Wherever we see a P, we replace it with an F. Wherever we see a Q, we replace it with an F because that's the assumption. Now we work it out. I got to take care of the negation first. Again, typically it's just natural how you have to work the operations, right? Because you just can't do something before you know the value, right? How can I evaluate this if-then if I don't know what the left side is, right? So again, it sort of just naturally flows. You tend to work left to right. When we get to the truth tables, you see that. All right, over here, negation of a false is true. On the left-hand side, we have an if-then. A T gives an F, that's false. On the right side, we have a false gives a T, that is true. If and only if is true when they have the same truth values. They do not. So this statement here is false under this scenario. Moving on to number 7. We're assuming P is false and Q is false. Substituting in, false gives a not false or false. So false yields true or false. And if then, this one is true. Or is true when at least one of them is true. So this statement here is true under that scenario. Now number 8 is a little bit different. We want to determine when this statement is true or false. And this actually leads us to the discussion of truth tables, which is in the next snapshot. We need to know when this statement is true. Well, there are 4 possible scenarios that can occur. I'm going to walk you through each one. It could be the case that both P and Q are true. When they're both true, we get this statement. Working it out, we get a true statement. It could be this scenario. P is true, Q is false. Under this scenario, you can stop the video if I'm working too fast for you. I try to keep my video length within reason. So I'll replace Q with F, P with true, working it out. This statement's true under this scenario. There's a third scenario. P could be false and Q could be true. Substituting in, replacing P with false and Q with true, working it out. This statement's true. And then the last one, they both could be false. Substituting in. And then again, it's true. This statement we just found out is always true because we have looked at every single possible scenario that could have occurred. If we were talking about the blue dog and the red cat, no matter what turns out, the dog is blue, the cat is red, and the dog is not blue, the cat is not red. No matter what I said, whatever happens, whatever I said here, I did not contradict myself. It is always a true statement. So we did a lot of work here. We can organize that work in a little bit better format by constructing what is referred to as a truth table. That is done in the next video. So I hope this helps. Again, I'll work through this rather quickly. You can always rewind the video and watch it again. All right? So good luck.